Assalamualaikum and very good day everyone. Welcome to our exciting introduction to the world of chemical engineering. Have you ever wondered what chemical engineering is all about? Well, today we are not only going to explain it but also introduce you to a cool unit operation that is a big part of this field. Especially when you are a pre-university student who loves chemistry and physics, you might be considering chemical engineering for your degree. But here's a surprising fact. Chemical engineering is about 10% chemistry and also 90% of physics and mathematics. Yep, you heard that right. So stick around and watch this video till the end before making your decision. As a third-year chemical engineering student, I can tell you that this degree is incredibly interesting and diverse. It is like being a jack of all trades. We learn a bit about other engineering fields such as electrical engineering, programming, safety and health, pollution control and many more. One of the most exciting yet challenging part of chemical engineering is dealing with fluid dynamics, which is constantly changing. It is like solving a new puzzle every day. So, if you are curious and ready for an adventure in learning, chemical engineering might just be the perfect fit for you. Today, I'm super excited to introduce you to the fascinating world of chemical engineering. So, what is chemical engineering all about? Imagine a program where you get to dive into awesome lectures, tackle cool assignments, and do hands-on experience in the labs, just like other engineering courses, but with a twist. In the beginning, you will start with the basics. You will learn about calculus, trigonometry, organic chemistry, and thermodynamics. These subjects build a strong foundation for your future studies. Next, you will explore the core of chemical engineering, things like material balance, energy balance, and fluid mechanics. But that is not all. You will also get to learn computer-aided design, programming techniques, and even some electrical engineering basics. One of the coolest parts, ton of group works. This helps you develop awesome communication skills and teamwork. As you progress, you will dive deeper into crucial areas for chemical engineering, like separation process, chemical reaction engineering, process control, and plant design. And do not worry, we have not forgotten about the environment and safety. You will learn about those too. Toward the end of your study, you will tackle exciting undergraduate projects, internship, and plant design tasks. These are all key to becoming a skilled chemical engineering design. And do not worry, we have not forgotten about the environment and safety. You will learn about those too. Toward the end of your study, you will tackle exciting undergraduate projects, internship, and plant design tasks. These are all key to becoming a skilled chemical engineering.
So, I'm sure many of you want to know what kind of field is related to chemical engineering. Chemical engineering is a broad and versatile field encompassing a wide range of roles and is utilized in numerous industries from energy and pharmaceuticals to environmental protection and material science. This diversity offers countless opportunities for those who equip with a chemical engineering degree. Here are some of the career options where a chemical engineering degree is particularly valuable. First is biotechnologies, and then chemical engineer, energy engineer, or product development engineer, and also quality control engineer. Now I will introduce to you one of the processes in chemical engineering, which is absorption. What is absorption? Absorption is a process in which one substance is taken by another, typically occurring when a gas or liquid interacts with a solid or liquid, leading to the incorporation of one phase into another. This phenomenon is essential in various engineering applications, particularly in mass transfer operation, where it facilitates the removal of specific components from a mixture. The efficiency of absorption process depends on several factors, including concentration gradient, temperature, and the nature of the materials involved. Common applications of absorption include air pollution control, where gases are removed from exhaust streams, and in chemical processing to separate valuable products. The design of a absorption system often involves calculating mass transfer coefficient to predict how efficiently the absorption will occur. Stripping is often used in conjunction with absorption to recover the absorbed solid from the absorbent, allowing for recycling and reuse.
Next, I would like to talk about the working principle of pack absorption towers. A pack towers loaded with a large number of tower packings and internals is a common gas liquid mass transfer equipment. Liquid enter from the tower top and is evenly distributed onto the tower packings through the liquid distributors and then flow down along the packing surface. The gas enter from the tower bottoms and distributed evenly through the gas distributor device. The gas rises up against the liquid path through the void of the tower packings. The gas and liquid will contact the packing surface for mass transfer. When the liquid flow down along the packings, it tends to flow to the tower's wall, which makes the tower's wall liquid quantities increase rapidly. This phenomenon is called wall flow, which may cause the non-uniform distributions of the gas and liquids. To avoid it, liquid redistributors are placed in the middle of the tower bodies when the packing layer is too high.
Next up, we move on to tray absorption towers, where the liquid and the gas come into contact in the form of trays inside different stages. Rears maintain a layer of liquid on each tray, while the gas bubbles through openings inside the trays. The gas bubbles through the liquid, where some of the product is dissolved into it, and the remaining gas moves on to the next tray above. Overall, the contact between the gas and the liquid occurs inside multiple stages, although it's still a cross-flow contact of the two inside the tray. Here is another illustration for tray absorption towers. There are different types of trays used in absorption towers. The first one of which is sieve tray, where the vapor bubbles up through simple holes inside the tray through the flowing liquid. The depth of the liquid on the tray can be maintained by an overflow outlet weir. Another commonly used tray inside the industry is the bubble cap tray, where the vapor or gas rises through the opening in the tray into bubble caps, where the area is increased and the efficiency of the entire tower is also improved.
So I think everyone gets the big idea of how absorption works now based on previous slides. But what about the real life applications of absorption in different fields? So in real life, we can see that the absorption concepts can be applied in various fields such as environmental applications, healthcare applications, and in daily life applications also. So in environmental protection, when we look into air pollutions, the concept of absorption is often used and the device is called scrubbers, which is the image at the leftmost. So this device usually uses liquid absorbents to capture or absorb any harmful gases or greenhouse gases that we can turn it into environmentally friendly gas. These harmful gases often include sulfur dioxide, carbon dioxide, and then we absorb it through the scrubbers, and then we throughout some reactions in the plant, and then we can turn it into some environmentally friendly gases. So, furthermore, in healthcare applications, we can often see that there are some hospital-grade air purifiers or even normal air purifiers in your houses can have the abilities to use absorbents to capture any harmful contaminants, which ensures a clean air environment for patients or even children. So this concept is often crucial because of the viruses and the bacteria in the hospital, right? Because of how the environment is filled with patients. So it is important to consistently purify the air around the hospitals or houses to ensure a clean air environment and to ensure also the virus and bacteria does not spread. So, in addition, in simple life daily applications, we can often see those silica gels packets you found in the shoebox or leather bags, or even electrical appliances. Oh, this is due to absorb the moistures. They are absorbents that can keep the products dry by capturing the moistures in the content so that the product would not spoil easily. So, with all that, I believe everyone should now understand how absorption works and how it plays an important role, not only in chemical engineering field, but also part of our lives. So, absorption is a critical process widely utilized in various fields such as environmental, healthcare, and daily life applications. The ability to selectively bind substances from a mixture makes it invaluable for applications such as water purification and gas separation, and also catalysis. The application itself is very diverse and impactful, and it's improving our life quality. And that is all from us. Thank you.